Hey folks, here's another question of electrostatics. It says a small sphere Q1 with a charge of 32 nanocoulomb is suspended from a light string secured to a support. A second identical sphere Q2 with a charge of negative 55 nanocoulomb is placed in a narrow cylindrical glass tube vertical below. Each sphere has a mass of what? 7 kg. Both spheres come to equilibrium when Q2 is 2.5 centimeter from Q1, as shown in the diagram below. Ignore the effects of air friction. Guys, this Q1 is positively charged, is supported by that tension. There's a tension force that it experiences there. And then there's another charge here in this tube, which is negatively charged. There's an electrostatic force between the two. There is a force between the two, the electrostatic force, and these two guys are at equilibrium, which means they are not moving. They are at rest, both of them, right, at this distance. And this one is negatively charged, right? That's very important. So the forces that are acting, guys, on this one, it's the tension force, it's the electrostatic force in that direction downwards. The forces that are experienced by it's an electrostatic force in that direction, and there's a gravitational force. And the forces that are experienced by this one, it's an electrostatic force in that direction, and the gravitational force, no tension in this one, the vertical forces, right? Now the question now, it says the sphere, no, calculate the number of electrons that were removed from Q1 to give it a charge of 32. Assume that the sphere were neutral before charged. Guys, now since it's positively charged, that means it was neutral before and then it was charged. Now it has lost electrons, so we wanted the electron that it has lost. So guys, the only thing that we do there, we use the quantization of charge. So it's Q is equal to N is equal to Q over Q. And then that charge is positive. It's going to be 32 times 10 to the power negative 9 divide by, if I'm using positive, I have to divide by the positive 1.6 times 10 to the power 19. And then guys, always your answer here needs to be positive. So your answer is going to be 2 times 10 to the power what? 11. Both this, it needs to be positive, and your power needs to be positive. So these are the electrons that were removed from this one. Since it's positive, there are electrons removed. Then 7.2, it says draw a label free body diagram showing all the forces acting on sphere Q1. As I've mentioned, guys, on sphere Q1 there's a tension force that is going up, right? And then there's an electrostatic force that is going down. Okay, I think I exaggerated that. There's an electrostatic force that is going down, and there's a gravitational force. So there are two forces acting downwards there, the gravitational force and the tension force. But what you need to be mindful of here, since this since this is at equilibrium, that means the F net is equal to 0. Right, so that means your tension, the tension, it must be equal to the sum of Fg plus Fe, which is the electrostatic force. Sorry guys. So the tension, it has to be equals, if you're looking here, the tension, it must be equal to the sum of these two, because the net force is equal to 0. Right, now let's go to 7.3. 7.3, it says calculate the magnitude of the tension. Now we're going to use what I just mentioned. Now the magnitude of the tension is equal to the sum of these two, because the F net is equal to 0. Let me show you how. If you say F net is equal to, your F net is equal to, let's choose up as positive, down as negative. So your F net is equal to tension, that is positive, plus plus the Fg, that is negative, minus the electrostatic force, that is what? Negative, because they are going down. So you're going to have T is equal Fg minus electrostatic force. I hope that makes sense. And then we substitute the net force. Since it's at equilibrium, it's going to be 0. Right, so we're going to have tension is equal to Fg plus electrostatic force. I hope it makes sense, that maths there. So we want the tension. This is going to be what? Mg plus the electrostatic force is going to be K Q1 times Q2 over R squared. And then the mass, we're told that the mass is what? Is 7 grams, right? It's 7 grams, but the 7 gram, it's 7 divided by 1000. You have to change it into kilograms. So it's going to be 7 times 10 to the power negative 3. Let me show you here. 7 grams is equal to 0 is equal to 7 times 10 to the power negative 3 kilograms when you convert, times 9.8, and then plus, we are here now, 9 times 10 to the power 9, and then the Q, it's 32 and 55, 32 and 55, and the distance is 0.25. 32 times 10 to the power negative 9 and 55 times 10 to the power negative 9, and then the distance is 2,5. The 2,5 is going to be 0. That distance, guys, between them is 2,5 centimeter. You have to divide by 1000, which is going to be 0,025 square. So if you punch the entire thing in the calculator, it will give you the answer. When you punch that in the calculator, you punch the entire thing. You can do it separately as well. So the answer here, it's going to be 9,39 times 10 to the power negative newtons. That's the force, that's the tension force there. I hope, guys, that makes sense.